Assalamualaikum everyone and welcome back to my channel. So in this today's video we are going to discuss another important topic, and this topic is about hydrolysis. So why we are discussing it? So actually hydrolysis is a process by which our drug is undergoing the process of instability. So actually this is the topic which is included in the causes of instability of drug. Okay, so now we are going to study that why our drug are going to unstable. So the one of the major cause of instability of drug is the one which is hydrolysis, and the second cause is the oxidation. But in this lecture we only discuss the hydrolysis. So first of all, we are going to see the definition of hydrolysis. As you can see here, hydrolysis is a process in which there is a breakdown of a substance in the presence of water. So your water is consist of two ions, hydrogen ion and hydroxyl ion. So these two ions react with the ions of the drugs and they get soluble into each other. So therefore this is called as decomposition, because your drug is undergoing the process of decomposition and breakdown in the presence of water. So therefore it is called what? Hydrolysis. The word hydro means what? Your water, and your lysis mean breakdown. So your drug is going to be breakdown in the presence of water. So the decomposition of a substance in presence of water molecule is called hydrolysis. So this is the definition of your hydrolysis. So actually why the hydrolysis occur? Because many drugs are prepared and they have water in them. For example, if I give you some example, for example, the syrup has water in it. Various emulsions, they have oil and water emulsions. In the suspensions we also use water. So therefore in some drug we have to use water, but due to the use of water the hydrolytic reactions can be occur. So all the drugs, whether they are in the solid form, whether they are in the liquid form, they are affected by the moisture presence. So therefore we are say that the moisture can affect your drug and can cause it to become unstable, so you have to protect them. So there are some benefits of hydrolysis as well. So you cannot say that it is only has disadvantage, it is beneficial. And how it is beneficial, now explain to you. First of all, it is giving you the energy. What energy? It is converting your ADP into ATP. So it is giving you the energy which is most important for you and your body also. And the second thing is it is used in the preparation of various chemicals and pesticides. So that doesn't mean that it has only disadvantage. It is used, it also used to prepare various kind of explosives and paper and etc. And another important use of hydrolysis is that it is going to digest your food. Okay, in your stomach and various part of your body, your food is going to digest. Okay, for example, in the stomach the digestive juice is going to break down your food, and in the digestive juice you have 99% of water. So that's why it is important the digesting your food. And another use of hydrolysis is that it also produce soap by the sponification. And this sponification is a process in which your lipid is undergoing the ester hydrolysis, and then you are going to produce your soap. So these are some benefits of hydrolysis, and now we discuss some disadvantage of hydrolysis. So the benefits and disadvantages is not written in this topic, so you have to write it in the separate part. You can note down on your notes and on your register. So this is the another kind of additional information about the hydrolysis. So now if I explain the disadvantage, so I give you the example. For example, penicillin, you know very well about the penicillin. So if you are giving and providing the moisture exposure to your penicillin, then the chemical breakdown occur and this drug is became inactive. So there is a great disadvantage of inactive drug, because due to the inactivity this drug cannot be able to give its effective components to your body. For example, if I say you have a drug which is controlling your BP, and if this drug became inactive due to hydrolysis, and if you eat this inactive drug, then this drug has no effect on your body. It is not going to control your BP because it is ineffective. So this is the disadvantage of your hydrolysis, that it is going to inactivate your drugs. Now we are going to discuss the types of hydrolysis, which is very important. Majorly we have two types of hydrolysis: ionic hydrolysis and molecular hydrolysis. As the name indicates, they are very simple. So ionic hydrolysis means your water is going to react with the ions, okay? And which ions? The ions which are present in your drug. Your drug can have ions in them, and ions of salt of weak acid and a weak base. So actually your drug can consist of weak acids and weak base in them. So when you have weak acid and weak base, you know very well the ions are produced by these acid and base. And if the acid and base are weak, then they easily donate or accept the ions, and therefore there is a rapidly production of ions in them. So your water also consists of ions. For example, if you see the water decomposition, it consists of two ions: hydroxyl ion and hydroxyl ion, okay, O negative. And your drug can also has a positive and negative ion. So these ions is going to react. For example, if you see the example locating here, so in this example your water is a acid, okay, and it is going to donate hydrogen ion, and this is a weak salt base which have potassium, so therefore it is base. Now what is going to happen? It donates is hydrogen ion, and this hydrogen ion is going to attack and take the place of potassium, so it will become this acid. And the potassium is removed from here, and this potassium is going to react with the hydroxyl ion of the water. So when they both react, they are going to produce KOH, which is a base. So now what is going to happen? A weak acid and a weak base react with a water, and they are going to produce another acid and another base. So this is the type of hydrolysis in which your water react with either the base, either the acid, which can be acid, which can be, for example, in this case it is a base, but if you see in that case it is a acid. So that in this case water is acting as a base. So when the water with weak acid and weak base, they react, and they water react with the ions, and they give a production of new acid and new base. So now you are producing the new product. So this is also the benefit of hydrolysis, that you can break the old compounds to produce the new acid and new bases which you need. Now if you see the other type of hydrolysis is the molecular hydrolysis. Now you are going to break up the molecules of a drug, okay? Not all the drugs are composed of ions. Some drugs have molecules in them. For example, aspirin. Here aspirin is a compound which has a molecule in it. So if you are going to do hydrolysis, for example, aspirin hydrolyzed in the presence of a acid which is H positive ion, and it is going undergoing the breakdown, and it is going to produce salicylic acid and acetic acid. So this is called as molecular hydrolysis. Now let's see the theory of it. The type of hydrolysis in which your water react with the molecule of a compound and to give the molecular hydrolysis, and this is very important type for the drug instability. And various functional groups are present which can undergo the hydrolysis. For example of these functional groups are ester. The ester functional group readily undergo the hydrolysis, and we also explain what is the ester hydrolysis in this lecture. And your amide hydrolysis can occur. Thiol ester group readily undergo, and acid and hydrates. These are the some functional groups which can readily undergo the hydrolysis process. So the drug which contain these type of functional group can readily undergo the hydrolysis. So we have to protect these drugs, because if they are undergo the hydrolysis, then it has no beneficial for us. So we have to keep them safe. We have to prevent these drugs to undergo the hydrolysis. So how we can prevent them, I also explain this in this lecture. So now for this time we discuss what are the factors which can affect your hydrolysis. For example, first is the moisture. If your drug have high moisture exposure, then the hydrolysis will occur fastly. And if you see the effect of pH, then if the water is reacting with the acidic pH or with the alkaline pH, so it can cause the production of acid and alkaline environment. So pH also has a great effect on the hydrolysis. Another thing is the temperature. Whenever your temperature increases, the hydrolysis increases. Fourth is the type of solvent, that what type of solvent you are using. If you are using water or inorganic solvent, then the hydrolysis increases. And if you are going to use some organic solvents, then the hydrolysis gradually decreases. As the written here, you can see, move the more we move away from water to organic solvent, your hydrolysis decreases. So if you are going to use inorganic solvent, your drug will readily undergo the hydrolysis. So therefore we are going to prefer that we should use organic solvent in our drug for their formulation. So by using the organic solvent, we can decrease the possibility of hydrolytic reactions to occur. Okay. I hope that you understand all of these concepts. And if you have some question, then you can ask me in the comment section. I will give answer to you. And if you have a specific topic which you don't understand, then comment me. I will give the complete detailed video about it. And if you don't have to subscribe to my channel, then go press the bell icon and subscribe button, and also like my video. And if you like it, and please share it with your friends and your family. Thank you very much for subscribing to my channel. Now let's see what are the effects of hydrolysis. There are some effect of hydrolysis on the drug stability, because due to hydrolysis, drug is going to decompose, but it also has the benefit that is going to produce the new products. And the products which you have to use, and which is your desired product, you can produce from it. And maybe new products may be toxic in nature and also decrease the therapeutic effect of drug. So that doesn't mean that the new product will be beneficial or effective. It can be toxic in nature, so you have to prevent it. So if you eat the drug which new product is ineffective or toxic, then it can cause various effect on your body, various harmful effects on your body. Okay. Now we see what are the preventive measures against hydrolysis. So if you have a solid drug, okay, the drug which is in the form of solid, so how you can prevent it? You should have to use airtight vessels. Okay, you have to tightly pack this solid drug with the aluminium foil, so that there will be no exposure of moisture on it. And second thing, you can use the silica gel bags. Okay, so the silica gel bags are also act as a descanting agents, and they prevent the hydrolysis and moisture exposure. Second thing, if you have a liquid dosage form, okay, for example, if you have a drug or you have a syrup which is in the form of liquid, then how you can prevent it from hydrolysis? So you should have to change your aqueous solvent. You should have to use your unaqueous, yeah, non-aqueous solvents. So the example of non-aqueous solvent which you can be used are the alcohol. You can use a propylene, a glycerol, and glycerin can be used. For example, if you I give you the examples, aspirin. So how you can prevent the aspirin? You should use propylene glycol in the sol as a solvent in aspirin. So in this way you can prevent the hydrolysis. Second thing is the production of insoluble drugs. From various kind of insoluble drugs are produced, and you have to make them soluble. So you can use the solvent according to their need. So you have to selective careful in the selection of the liquid on which your drug is going to be soluble. And second thing, you have to adjust the pH. You should not what is the pH of your drug and what is the pH of your solvent which you are going to use, and then you have to combine up and see the reactions of them. So okay. Now fourth is the complex formation. You can add complexing agent in it. By adding the complexing agent, your drug will react with these complexing agent and will going to produce complexes. For example, caffeine is used in this reaction. So various kind of drug, for example benzocaine and procaine. So these kind of drugs, as written here, benzo cane drug. If you add benzocaine in caffeine, then it form the benzocaine complex. Okay, and in this way you can prevent the hydrolysis. Okay, so how the complex is formed? Your complex is formed by adding caffeine in the benzocaine, and by adding them you can form and give a complex which is called as benzocaine complex. So by forming these complex we can also stop hydrolysis. Last thing is that the packaging, you should have to keep the packaging as possible as you can. So you should have to use disgusting agents, sorry, desiccant agents. I This as written here, desiccant agents are here written, so you can use them. And you can also use the aluminium foil. Okay, you can use aluminium foil for this purpose. And these two things help you in the packaging of this kind of drug. Another preventive measures which are not written in this PDF file, you can add up this into your notes, that a buffering agent. You can add the buffer in your agent, so a buffer will minimize your pH and make your drug stable. And one thing you have to keep in your mind is that you should have to add buffer in a very minimum concentration. So whenever you increase the concentration, then sometimes the components of buffer also undergo or promote the hydrolysis, so you have to keep the minimum concentration of buffer. Next thing is that you have to suppress the portion which is undergoing the hydrolysis. For example, every drug, if I draw a drug here, this is the drug, and every drug has a portion which have ability to undergo the hydrolysis. For example, if we say this drug has this portion, so this portion have a great capability to undergo the hydrolysis, so you have to suppress this portion. And how you are going to suppress this portion? By adding emulsifier or by adding surfactant. So surfactant is going to produce a protective covering around this portion and then decrease the hydrolysis chances. Second thing is that you have to change the dosage form. Okay, how you can change the dosage form? For example, I have explained to you that the penicillin can undergo the complexes because it is in the dry powder form. Okay, now you have to change the formation. For example, if the penicillin is in the form of liquid or in the form of solid, so what you have to change? You have to change its composition. First it is in the form of liquid, then you have to change it in the dry powder like form. Sorry for the bad drawing, but I just have to give you the complex or the concept. So first the penicillin in the form of liquid, now you have changed it into the dry powder like form. So by changing this kind of composition or dosage form, you have to change the appearance of dosage form. So by changing this appearance you can save your drug. And refrigerating is also a process by which you can protect your drug from hydrolysis. You can keep your medicines and into the refrigerator. For example, if you I give you the example of a drug which is CAC 100 cc plus. So this is the calcium drug, and this is the effervescent drug which you have to dissolve it in the water, and then you have to drink. So it is really affected by hydrolysis, so you should have to keep it in the refrigerator. So this is the some preventive measures of your hydrolysis, and some factors and some types of hydrolysis. Another types of hydrolysis which is not given in this PDF file are ester hydrolysis, amide hydrolysis, and ring hydrolysis. So I have explained this into you in this lecture, so please careful about it. So first we have ester hydrolysis. So in the ester hydrolysis, what is going to occur? Your acyl oxygen cleavages occur. For example, if I draw the ester group, this is the structure of ester. Okay, this. Now whenever it is going to hydrolysis, what is going to occur? You should use acid catalysis for this reaction, and in the presence of water and carboxylic acid, and alcohol is going to produce. So now you see the new products are obtaining by this hydrolysis. And what types of drugs can undergo the hydrolysis? So there are four types of drugs which can undergo this type of hydrolysis, and I have a mnemonics to learn these types of drugs. For example, patan. Patan is the mnemonics to learn or to remember these drugs. So for from the P, you should revise the name of a drug which is called as procaine. Okay, note this type in your register. This is very important. From the A, you will get aspirin. Aspirin also undergo ester hydrolysis. From the T, you will get a drug which is called as tetracaine. CAINE. Okay, now next drug name is from A, and this drug name is atropine. So from this mnemonics you can learn four drugs which can undergo ester hydrolysis. Okay, I hope that you will learn it. Next is the amide hydrolysis. So amide group I have drawn here. This is the amide group, as you can see here, N R or H. So this is the amide group. So in the presence of water, the breakage will occur here, and the two compounds will be produced. First is the carboxylic acid, okay, and second is the amide group. Amine, okay, not amide. This is the amine group, this is the amine group, and this is the amide group. There is a difference between them, so you have to keep this difference in your mind. And the drugs which undergo these amide hydrolysis are barbie nickel guy. So this is the mnemonics for this to remember the types of this drug. What is the mnemonics? Bar बी, ठीक है, बारबिया या बारबी आप कह सकते हैं, निकल गई. Okay, sorry for the bad writing. It is very difficult to write on the screen, so therefore you should have to minimize it. So from the barbie, it is barbiturate. Barbiturate. So okay, barbiturate, TE आना है, ठीक है. Then from the N, you have a drug name which is called as niacinamide. Niacinamide, it can undergo MID होता है, ठीक है. I cannot write the whole spelling on this. So these are the two drugs which can undergo amide hydrolysis. Then the last is the ring hydrolysis. Sometimes ring hydrolysis can occur, and this is occurring due to the when you have a hydrogen or hydroxyl group which can attack on your. First I am drawing this ring, and in this ring what is going to happen? Some hydroxyl ions can react with it. Okay, so this is the ring, and in this ring hydroxide group is going to react, and this ring opening will occur. And how this ring is going to open, like that form as I am drawing. So this hydrolysis can cause a ring opening. So as you can see here, this is the lactose hydrolysis, and in the lactose hydrolysis the ring is going to open due to the attack of hydrogen or hydroxide ion. And what kind of drugs are going in this ring hydrolysis? First drug is the Ben, benzo, diazepines. ठीक है, this is the first name of the drug. Second is the penicillin. It can undergo the ring hydrolysis. Then you have a chlorodiazepinoxide. Chlorodiazepinoxide. So this is the first, second, and three names of the drugs I have given to you, which can undergo the ring hydrolysis. So this was all about the today's lecture, and I have explained all of these terms to you, and I hope that you will learn everything from this lecture. If you have some confusion, then you can ask me in the comment section. I will answer to you. And if you have don't subscribe till up to my channel, then go first press the bell icon and subscribe button and become the part of my YouTube family. Thank you very much for listening me and for gaining the concept from my YouTube channel, and keep sharing my YouTube channel and saying it. Thank you very much for watching this video, and meet you soon in the next lecture with the next topic. And take care of yourself and remember me in your prayers. Allah Hafiz.